What is up people, and welcome to another video on the Kubernetes Lightning series, where we take a look at Kubernetes from scratch, from the beginning. In previous videos we've installed Docker, and then we used Docker to bootstrap a Kubernetes node using a utility called kind. So now that we can build containers, work with containers, and we have a cluster, this video is going to be all about kubectl, how to interact with a Kubernetes cluster. There are many ways to interact with Kubernetes. There are a lot of dashboards and tools you can use, but the native way to talk to Kubernetes is through the API. Every Kubernetes cluster has an API endpoint, and to talk to that API endpoint, we use a command line utility called kubectl. So we're going to take a look at downloading kubectl, how to configure it so that we can point it to a Kubernetes cluster, take a look at some of the concepts, configuration, and commands. So we got a bit to cover, so without further ado, let's go. So to start, I have access to a Windows computer, and for compatibility and for Linux and Windows folks, I'm running all of this setup in Windows subsystem for Linux, so it's fully Linux compatible as it's running on a Linux system. In the previous video we've installed Docker within WSL, set it up using all the steps for Linux, for Ubuntu Linux specifically, and we've installed a utility called kind. So if I jump into a terminal and I just type docker ps, you can see we have a kind cluster that is running. This is a Docker container that acts as our Kubernetes node. After installing Docker, in a previous video we've taken a look at cloning the Docker development YouTube series so that we can have access to a container. We use the Docker file to build a container and run it. If you need access to the source material, check out the link down below. If I fire up VS Code, you'll find the Docker container. On the root, there's a Python folder. In the Python folder, there is a Docker file. This is the container we built in the previous episode. In the source folder, there is source code with a server.py. This is our Python application which runs Flask. It's just a minimal web API. Now the other reason this repository is very useful, if you look at the folders, you'll find a Kubernetes folder. If you expand that, you'll find a kubectl folder, and there's a README in there. And this is a video that I've done about the introduction of kubectl, where I've covered a lot of the stuff in lots of detail. So if you need more content on kubectl, search for kubectl on the main channel, and I'll be using this guide as a reference. So there are a number of ways to download kubectl. Now as we'll be running on WSL, we'll be technically using a Ubuntu Linux environment. So I'll go through the Linux install, but I'll also show you the Windows install if you're interested. If you hop over to the guide, the boring way to do it is just download kubectl by going to the official docs. If you click on that, that'll take you to the installs tools page on the official Kubernetes documentation. If you scroll down, you'll see the kubectl is right at the top of the installs page. There are 3 links you can download for Windows, Linux, or Mac OS. For Windows, just go ahead and click on that, and that'll take you to a number of ways you can actually install it on Windows. The easiest one is just to use curl, and you can replace the version right over there. You see the latest one is v1.31, and that'll just download kubectl.exe. So you can go ahead and grab this, and what you want to do is paste that directly in a PowerShell window. What I will do is go to my C drive, and I'll just create a tools folder. I'll say mkdir tools, and I'll change directory to that, and I'll put this directory under my path. Go ahead and run this, download kubectl into this tools folder, and then what you do next is add this to your path. So if you click the start button and search for path, you'll see the edit the system environment variables. Go ahead and click that, open it up, then click on environment variables, open that up, and you can either set this user or system wide. I'm just going to go for the user. I'm just going to edit that, and I'm going to add a new folder here. Just say tools, go ahead and add that, and then click OK, and click OK, click OK, and if you type kubectl now, you'll see that kubectl works. And if I run the kubectl version command, you can see we have client version 1.31. This is the version of the kubectl binary that we just downloaded. And this binary is sitting in our tools folder. If we want to install it on Linux, we can follow the same process. Go to our guide, go to the official documentation. On the install tools page, we go to install kubectl on Linux, click that, And we have a similar instruction that we can use curl, and we can just go ahead and download the latest release using curl. So I'm going to go ahead and copy that, going to jump into Linux, and I'll go ahead and curl that binary. And that'll download kubectl into the working folder we are in right now. If I do ls, you can see the binary right over there. So what we want to do is move it to user local bin. I'm going to say move kubectl to /user local bin /kubectl, and I think I might need sudo for that. So I just append sudo in the front, give my password, and we're good to go. If I type kubectl version, you can see kubectl is now installed in our Linux system. So very simple to install kubectl. And now that you have kubectl available, the next thing you're going to need is a kubeconfig. Now there are a number of ways that you'll get a kubeconfig depending on Kubernetes that you're using. If you're using something like a cloud provider, DigitalOcean, Linode, AKS, EKS, GKE, you'll have to use their portals to download a kubeconfig. If you're using Kind will automatically create a kubeconfig when you create a cluster. It's important to know where to find your kubeconfig file. Now the kubeconfig file is usually found in your users directory, and that is by default under C, users, and then the name of your user, and then .kube. .kube is actually a hidden folder, so if you want to view it on Windows, you need to enable hidden folders so that you can see hidden folders, and then inside there will be a file called config. This is the default path that kubectl will look at to find a kubeconfig file. If you're on Linux, it'll be something like user path, which is defined by the tilde character, then .kube and config. So this is the default for Linux. We can see this by jumping back into our WSL, and we can say ls, the users directory, the .kube folder, and we see a config right there. That is the default config, and in our case this is created by Kind. If you just install kubectl, you will not have this file at all. You need to either go to a cloud provider, download the file, or use Kind to generate the file for a Kind cluster. And to verify that kubectl is picking up that config file, we can use the kubectl config command. If you type kubectl config and you say view, it'll print out the config. And it's important to understand the structure of a kubeconfig file. There are three components that you need to know about. A kubeconfig always has a list of clusters. A list of clusters is basically just an array of names. So what do we call our cluster, and the server address. Where is this cluster located? This is generally always an HTTPS link, either an IP address if you're using Kind or some on-prem Kubernetes service, or you have a DNS value in here if you're using a cloud provider. This will be like an Amazon, an Azure, or a Google address if you're using one of those cloud providers. So this tells kubectl where to locate the cluster. The other important one is the list of users. This tells kubectl how to authenticate with that cluster. Generally by default, Kubernetes uses certificates to authenticate. If you're using something like a cloud provider and you have some sort of OAuth integration where you're logging in with a Microsoft or a Google or Facebook account of some sort, you're using an OAuth extension, you may not see a certificate there, and you may see refresh tokens and other sort of IDs that identify your user. So that's the user section. The last important piece is what's called the context. This is probably the one you're going to be using the most. The context is what binds the cluster and the user together. So think of context as your environment. So you might have a context called dev US East, and there you'll have a dev US East user and what cluster to use. The context basically tells kubectl what cluster to use and what user to authenticate. So you could have like a dev context or a prod context, and so forth. You could have multiple dev contexts or multiple prod contexts. This is basically what the kubectl config looks like. To tell kubectl what cluster to look at, you can say kubectl config current context. It'll tell you the context it is currently set to. You can see it's set to kind test, and that's over there. Current context is kind test. So we're currently pointing to a kind cluster located at this address, and when we sign in, it'll use this certificate to authenticate with it. You can switch context by saying kubectl config use context, and the name of the context, in our case kind test, but we're already on that context, so it's not really going to switch anything. So the kubectl config command is what you use to switch clusters. So you can switch from your dev to a prod cluster, for example. Now, I don't like to use the default config. This is generally just for local development. And the reason why I don't like to use the default config is because when you run kubectl commands, you can be pretty destructive. You can say kubectl delete namespace, or delete pod, or delete deployment, and you can end up running commands accidentally on your development or your production environments. So I like to use the default config, the one we looked at now, purely just for local kind clusters. We can tell kubectl to look at a different place for a config. So if you explicitly want to access your development or your production environment, you can run a one-liner command to set an environment variable to tell kubectl to look at a different config. So to do this, we can export a variable called kubeconfig, and we can point it to another file. So we can create another environment called devconfig. If we set that and we say kubectl get nodes, you'll see that it won't be able to connect to anything. If we say kubectl config view, it's going to be empty. That is because there is no kubeconfig that exists in this location. We can tell kubectl to just look at the original config, and we're back to a working system. Kubectl get nodes, you can see our node is up and running. So that's just a handy way to tell kubectl to look at a different location, and you can set up multiple kubeconfigs for development and production environments. Very useful thing to start off with, especially when you're learning. Now, if you're new to Kubernetes, what you want to do is create a checklist of all the Kubernetes objects that you want to learn about. This is because Kubernetes, basically you work with the cluster by interacting with objects. And I'll give you some examples. If you take a look at our kubectl page, there's a section on working with Kubernetes resources. And the first command you'll use quite a lot is the get command, kubectl get. When you specify get, you need to give a resource. For example, a namespace. You say kubectl get namespaces, it'll return all the namespaces. And this is where you have different types of resources like kubectl get pods, kubectl get deployments, kubectl get services, config maps, secrets, and ingress. There are way too many objects to cover in this video, so I'm just going to be really brief with one or two of them, just to get you started with kubectl. And then in future videos, we'll take a look at pods, deployments, services, config maps, secrets, ingresses, and so forth. But feel free to check out the Kubernetes documentations on what all those means, so you can start playing around with kubectl and play around with your kind cluster. So the first command is kubectl get. But kubectl also has a create command. So you can also use kubectl to create resources by using kubectl create. And here in this example, I say kubectl create ns example app. So I create a namespace. Ns is short for namespace. Some resources have an abbreviated name. So you can say kubectl create deployment, or you can say kubectl create deploy. You can say PO instead of pods. You can say SVC instead of services. Those are just some tips. And the kubectl create command is pretty powerful. You can see I have examples here of creating an entire deployment with pods, creating a service to expose that deployment, port forwarding, creating a config map, and creating a secret, all using a combination of the create and the get commands. So let's try that. Let's create a namespace. So I'm going to say kubectl create ns example apps, go ahead and create that, and then I'm going to create a bunch of resources in that namespace. I'm going to say kubectl in the example apps namespace, create deployment. I'm going to create a web server using an Nginx image running on port 80. Go ahead and run that. Now this is just to showcase the power of the kubectl create command. If you're new to Kubernetes, you may find this part overwhelming, but don't fear, because we will break it all down in simple terms. And when you're deploying and creating Kubernetes infrastructure, we won't be using the kubectl create command anyway. We'll be defining our resources as code using what's called YAML, and we'll take a look at that in the next video. But for now, I'm just going to show you the power of kubectl. We can then use the kubectl get deploy command to show the deployment that we just created, and there it is. There is one pod running, and the deployment's name is web server. It was created 65 seconds ago. Then I say kubectl in the example apps namespace get pods, and there's our pod. Now that pod is currently running, and it does not really have a public endpoint. It doesn't have an endpoint at all. It only has a IP. If I do get pods, and I say output as wide, we can see the internal IP address of that pod. However, this IP address may change, so it's not a good way to set up networking if you want other services to call this pod. We'll take a look at pods, deployments, and services in a future video. So now I go ahead and I say kubectl create service, and I'm going to create a service for that web server that exposes port 80. And I can say kubectl get service to view that service. You can see that service also has an internal IP, but the cool thing about services is that it actually gives us a DNS name to contact that pod. And kubectl has a port forward command that we can use to access these private services. So when we start doing Kubernetes development, we may not want to make all services public. We use the port forward command in kubectl to test out our applications by connecting via a private tunnel to their port. So what we want to do is we actually want to port forward to this service that we've just created. So we say kubectl port forward to the service web server on port 80. Now I actually have something else running on port 80, so I cannot expose that. So what I'm going to do is I'm just going to use port 8000 for this demo. And if we open up localhost port 8000, you can see we can hit our Nginx web server. So that is the kubectl port forward command to hit a port on a pod or a service. Now generally when we use the kubectl create command, we'll be passing YAML to kubectl instead. One of the powers of Kubernetes and one of its strengths is that we define infrastructure declaratively. So what does that mean? In traditional infrastructure, when you're writing scripts, you're generally writing them line by line. So you'll write a script that creates a server, you'll write another script that adds some configuration, you'll add another bunch of scripts that maybe checks if files or folders exist. If they don't, create them, configure them, then install all your applications. You do all this type of scripting. Scripting is generally called imperative commands. That is because they run one by one by one by one. The problem with imperative scripting is that you cannot guarantee that the state of the server is what you want it to be. Because I may develop a script, I may run it on my server and get an outcome that I'm happy with, but if I give you that script may not run successfully on your environment, even if the environment is identical. Sometimes network hiccups happen, or a script is unable to accomplish something and you have to rerun it. And not all scripts are rerunnable. In order to have a script rerunnable, you have to write it in such a way. For example, if your script creates a file, the folder where you're creating that file might not exist. So your script has to be written in such a way that it checks if the folder exists and then creates it. Doing this becomes really complicated in a traditional DevOps world. This is why Kubernetes, instead of focusing on imperative and sort of scripting model, it focuses on desired state. You tell Kubernetes exactly what you want, similar to the kubectl create commands we've just did. We told it we wanted an Nginx web server on port 80. We told it we want a service in the front, which exposes it. We tell it we want a configuration or a secret, and Kubernetes makes it happen. It has controllers which run in the background and make sure that the desired state is met. This is why in Kubernetes we're going to be writing our infrastructure as YAML files. We don't want to be writing hundreds of kubectl create commands, because what if one of them fails? If there's a network hiccup and it's trying to contact the API server and we've got 100 lines of script and only 90 of them pass, half our records would not be created. Instead, we'll use the kubectl create or the kubectl apply command, pass a YAML file in, and all of the infrastructure will be defined in that YAML file. Now, once resources are created, you can actually extract the YAML by using the -o flag in kubectl. So kubectl has a way of getting YAML out of the cluster. This is very important if you have something deployed and you have something in GitHub and you want to compare if the YAML is the same, or if someone has made any tweaks to the YAML. And to get the YAML for resources, you can use the kubectl get command, get the object you want, and say -o YAML. And I'll show you how to do this. You say kubectl get deploy, and we have a deploy called web server, -o YAML, and that'll output the YAML of that deployment. And in this GitHub repo, if you're interested to look at the YAML, I do have an example where we go ahead and we actually create a WordPress site using the kubectl apply command, and we pass a YAML file, and in this case actually a whole folder for kubectl. And if you're interested, in my kubectl guide I actually have some directions on creating resources from YAML files if you want to try it out. If you check the GitHub repo, I have a section where I say create resource from YAML file, and here we create a WordPress namespace and we actually apply a folder. So kubectl apply or create command can accept either a file or a folder. If you pass a folder, kubectl will go ahead and apply all the YAML in that folder automatically. So in my GitHub repo under the Kubernetes folder, if you scroll down, I have a tutorials folder and there's a basics folder in there with YAML. And in here I have deployment, ingress, services, stateful set YAML, a bunch of infrastructure that I can go ahead and deploy. So I create a new namespace by saying kubectl create ns, and I'm going to create a namespace called WordPress site, and then I'm just going to deploy everything, all that YAML into that namespace by saying kubectl in that namespace apply -f and pass a folder. But to do that, I need to be inside of the Docker Development YouTube series folder and then go ahead and run that. That'll create all the different resources and it'll print them to the screen. So the kubectl apply command is very, very powerful. We can create all our infrastructure as YAML and then apply it to our cluster. And this YAML can live in our Git repos and we can use CI/CD tools to apply it to our cluster as well. This is where things like Argo CD and GitOps utilities like Flux and all of these other tools come in, and they become very important because they'll take our YAML and apply it to our environments. And to clean up my resources, I can just say kubectl get ns to get the namespace, and I can say kubectl delete ns, and I can go ahead and delete that namespace to clean up my cluster once I'm done. Now, namespaces are really important because they allow us to group resources together. We can have namespaces per teams or per departments or per business units, and then deploy all the set of services for those business units in their own namespaces. And namespaces also allows us from a security perspective to give people access to the right resources. So one team can only see their resources because they only have access to their namespace. So namespaces help us isolate and group resources together. So that concludes it for this video for our Kubernetes Lightning series on kubectl. Now stay tuned because in the next video we'll take a look at YAML and we'll start looking at how to create Kubernetes infrastructure in a lot more detail. Now if you liked the video, be sure to like and subscribe and hit the bell. And make sure you follow on social media to get an update on the development of the Ultimate DevOps course. And if you want to support the channel even further, be sure to hit the join button down below to become a YouTube member. And as always, thanks for watching, and until next time, peace.